So this is part C, the last part of 2007, number 2, which requires the use of a graphing calculator. And what we're asked to do in part C is we're asked to find when the amount of water in the tank is the greatest, and then to compute the amount of water at that time, and then to justify our answer. So if we want to know when the water level is greatest, that should hopefully tell you we're looking for an absolute max. When we're looking for an absolute max or an absolute min for a function on a closed interval, what we can say is that that's going to occur at either the endpoints of the interval or at a spot within the interval where the derivative is 0 or where the derivative is undefined. This is a little bit of a tricky situation to take that approach with. I'll mention it briefly, but then I'm going to kind of back off and kind of go a different route. This is the rate that water enters. This is the rate that water leaves. So if we just want the rate of change of the water level, I'm going to define this function over here and then not really do much with it. I'm going to call it n of t. It's a net rate function, and I'm going to define it to be the rate that water enters minus the rate that water leaves. So the rate of change of the water level is going to be the rate that it enters minus the rate that it leaves. If we recognize that this is a rate, this is the derivative of the function representing the amount of water in the tank. So we would have to figure out when this function is 0, when this function is undefined, to get our candidates in place. We will list those out, but then we're not going to really check the water level at each of them. We're going to kind of eliminate some using some arguments that we made in part B a couple minutes back in the other video. So we do have endpoints of an interval here. We're supposed to be concerned with the interval from 0 to 7. So our endpoints would be t equals 0 and t equals 7. Maybe the water level is greatest at the beginning of this time frame, maybe it's greatest at the end of this time frame. Maybe it's greatest at some point when n of t, our net rate of change function, is equal to 0. So when is f of t minus g of t going to equal 0? Well, f of t minus g of t is going to equal 0 when, if I add the g of t to the left side of this equation, it's going to say g of t equals f of t. So that would be at this time right here and also at this time right here. So we have two places where the derivative is 0. They would be 1.617, the t-value of the first intersection, and then the t-value of the other intersection, which is 5.076. There's one place where this derivative would be undefined. This derivative is undefined at the t-value of 3. G of t is undefined at 3. That's where this big jump happens from the water level going down at 250 gallons per hour, or the water leaving at 250 gallons per hour, to the water leaving at 2,000 gallons per hour. So at t equals 3, this is undefined, making our net rate function, or our derivative, undefined. And so this is one last candidate. One way to figure out where our absolute max is, or where the water level is greatest, is to figure out the amount of water at every single one of these times. I'm not going to do that. We're going to kind of eliminate some of these so we don't have quite as much work to do. Let's think about whether or not we can eliminate 0. What's happening immediately after 0? Is the water level going up or going down? Well, immediately after 0, the rate that water leaves is above the rate that water enters. So our graph for the water level would start at 5,000 because they tell us there are 5,000 gallons in the tank at t equals 0, and then it's going to go down initially. So that could very well be the high point of our graph as we continue to graph the rest of the function representing the water level from 0 to 7. So this we're going to have to realize is a candidate. The nice thing is we don't have to do any work to find the water level at t equals 0. They give that to us in the problem statement. They tell us we have 5,000 gallons. We're going to have to see if we have any values at some of these points in between 0 and 7 where the water level exceeds this, or maybe at 7 the water level exceeds that. Let's go to this next value at 1.617. Well, at 1.617, that's the end of an interval where the water level is decreasing. At t equals 1.617, the rate that the water enters exceeds the rate that water leaves on the other side of that, meaning our water level is going to decrease until 1.617. And then on the other side of that value, it's going to increase. It increases until we get to the t-value of 3. At the t-value of 3, we have a switch from what the graph of g of t looks like. G of t is below f of t, between 1.617 and 3. So the amount of water that enters is bigger than the amount of water that leaves from this t-value to this t-value. So we are going to have to figure out what happens at t equals 3, and I guess I didn't really say why we're not going to consider this as a place for the max, but you know, this graph should hopefully convince you why I'm not going to consider it. That's a place where the graph is going to bottom out, not a place where the graph is going to top off. Now at 3, we are going to have to figure out what happens there. We're not going to have to figure out what happens at 5.076, because 5.076 is again the end of a time frame where more water is leaving than entering. So if more water is leaving than entering, that's going to indicate another place where the graph bottoms out. So this other place where the graph bottoms out is going to be the other intersection point, 5.076. This point right here happens at 3, so I don't have enough room to fit it on the axis there. But it's going to top off at 3, it's going to decrease until we get to 5, and then it's going to increase because more water is entering than leaving across the last piece of this time frame. The rate that water enters is above the rate at which water is leaving. So we're going to rule these out as possibilities, but we are going to have to figure out the water level at t equals 3, and also the water level at t equals 7. So that's supposed to be t equals 7 there. So if we're looking for the water level at t equals 3, we know that we start with 5,000 gallons in the tank at t equals 0. We know a certain amount of water is added to the tank across this time frame. The amount of water that's added, similar to what we did in part A in the last video, is going to be found by integrating the rate at which water enters from 0 to 3. But then we're also going to subtract off the amount of water that leaves. And the amount of water that leaves is 250 gallons per hour across that entire 3-hour stretch. So we're going to have 250 times 3 being subtracted off of that. So now it's a matter of figuring out the value of this. To do that, we're going to need to go to the graphing calculator here. So let me just get my calculator ready to go. I'm going to do this integral a little bit differently. So I'm going to do this integral from the calculator. I could do it from the graph screen again, but I want to show you another option that you have. If you go back to the home screen, in the math menu, if you want to do a definite integral without having to graph anything, at the bottom of the math menu, second from the bottom actually, is this function integrator. If you choose that option, that will do the integral of any function you type in. So I want to type this function in now. So if I carefully type that in, so 100, and then I'm going to change the t to an x, so 100 times x squared, and then times the sine of the square root of x. You tell the calculator what function you want to integrate, you give the calculator a comma, and then you tell it the variable you want to integrate with respect to. Well, the variable that I put into the calculator was x, so I want to integrate with respect to x. Then you give it another comma, then you give it the lower limit of integration, another comma, upper limit of integration. I'm going to close the initial parenthesis that it gave us when we chose this option, and then it's going to think for a minute, it's going to give us the result. So over the course of this time frame from 0 to 3, this much water enters the tank. So at t equals 3, we're going to have 5,000 plus 870. I'm going to round this answer to the nearest gallon. That's what it asks us to do here, so I'm going to round that to 877 gallons, but then minus 250 times 3, minus 750 gallons that leave over that time frame, and at t equals 3, we have approximately 5,127 gallons in the tank. We also want to figure out how much is in the tank at t equals 7. We know how much is in there at t equals 3, so what I'm going to do is I'm going to start with that amount, 5,127 gallons at t equals 3, and I definitely put the wrong value there, 127 at t equals 3. How much enters the tank over the time frame from 3 to 7? Well, that's going to be found by doing this integral. and then minus the amount that leaves over the time frame from 3 to 7. Well, the rate that water leaves from 3 to 7 is given by 2,000 gallons per hour. So since it's leaving at 2,000 gallons per hour for 4 hours, the total amount that leaves is going to be 2,000 times 4. So if we can evaluate this, that's going to represent the amount of water at t equals 7. So if we go ahead and try to figure this out, I'm going to do this integral first. And I want to do the same integral that I did a minute ago, so I'm just going to make the calculator give that to me again. And I just need to change my limits of integration. I need to do the integral from 3 to 7 this time. So my lower limit would be 3. My upper limit would be 7. So that gives me 7,387 gallons that enter the tank from this time to this time. If we start with 5,127 at t equals 3, and this much is entering, so plus 7,387, minus the amount that leaves, so minus 8,000, 2,000 times 4, you have the amount of water at 7, which is below the amount of water at 3 and the amount of water at 0. So the amount of water in the tank is greatest at t equals 3. This is how many gallons are in the tank then.